Hi, I'm Jaisurya. I'm going to do the first question in MAT-104 EndSem assignment. So the question is like there's a container of 20k cubic feet volume and there's 600 cubic feet per minute rate of fresh air coming in and 600 cubic feet mixture of the like overall mixture going out. So like let's take YT as a rate of fresh not rate the fresh air amount of fresh air inside the container at any particular instant p, and it's given that y of 0 is equal to 0. So then y dash will be the rate of change of fresh air. So rate of change of fresh air will be the inflow rate minus the outflow rate. The inflow rate, it's given that 600 cubic feet of fresh air, so 600 minus the outflow there's 600 cubic feet of the mixture, but we only want the amount of fresh air. So like we know that y divided by 20,000 will be the amount of fresh air inside the container per unit volume of the mixture. So then for 600 mixture 600 cubic feet of mixture, this will be the amount of fresh air. So yeah, like this is the differential equation. We have to solve this equation to find y of t. So like if we solve this, like we can transform this equation into something sort of this, and y dash will be dy by dt minus 20,000 minus y. I'm just multiplying divided by 20,000 by 600 on the both sides, so it will be easier to solve. So like if we send this to that side and send this to this side, it will be having 20,000 by 600, then dy divided by 20,000 minus y will be dt. We can integrate this. So if we integrate this, we'll be having 20,000 by 600, which will come out. Then this will be nothing but ln of minus ln of this value, which is 20,000 minus y, and this will be nothing but t plus c because it's indefinite integration. Yeah, like if we solve this, we'll be having minus 100 by 3 ln of 20,000 minus y is equal to t plus c. We have to somehow get rid of this c value. For that we have this. With this we can use this to find c. Yeah. If we substitute t is equal to 0, then we will be having minus 100 by 3 then ln of 20,000, and we know that when t is equal to 0, y is also 0, so there will be nothing here. It will be equal to 0 plus c. So c is this value. We can substitute this in the original equation to find the proper equation. Minus 100 by 3 ln 20,000 minus y is equal to t plus c, which is this minus 100 by 3 of ln 20,000. I'm gonna send this c value to this side. We'll be having minus 100 by 3. We'll take this as a common from both sides. Then ln of 20,000 minus y minus ln of 20,000 will be equal to t. You can see that if we solve this, this is ln of a minus ln of b, which is nothing but ln of a by b. So I'm taking this minus also inside, so it will be ln of b by a 100 by 3, then ln of b by a, then this is 20,000 divided by 20,000 minus y will be equal to t. So we want the equation of y in terms of t, so we're gonna rearrange it such a way that we'll get t y as a equation of t. So like if we send this 3 to 3 by 100, that's it, and take of e, it will be, this equation will be nothing but t of 3 by 100 will be equal to this equation inside the brackets, 20,000 by 20,000 minus y. Then gotta rearrange some more. 20,000 minus y will be equal to 20,000 into e power minus t of 3 by 100. Sending this 20,000, that's it. No, sorry. Sending this y, that's it, and this 20,000 and e power minus t, that's it. 20,000 minus 20,000 e power minus t into 0.03 will be equal to y. So we finally get y is equal to 20,000 into 1 minus e power minus t into 0.03. So we got the equation. We can check if this equation is true, like substituting t is infinity, because when t is infinity, we know that the volume of the tank will be filled with fresh air, because like the graph will be somewhat like this, I guess. As t approaches infinity, the gas will be filled with fresh air. So like substituting t is equal to infinity, this term will become 0. Then we'll be left with 20,000, which is nothing but the whole volume of the container. So yeah, y is equal to 20,000. So our equation is true. So next we have to find what time it will be when the 90% of the container will be filled with fresh water. So 90% of fresh air, will be 20,000, which is the volume of the container, into 90 by 100 will be the y. So we can substitute this y in the original equation. Y is equal to 20,000 into 1 minus e power minus t into 3 by 100. Substituting y, so we'll be having 20,000 into 90 by 100 equal to 20,000 into 1 minus e minus t into 0.03. Solving this will cancel out, so this will be 0.9 over here. We send this term to the left side, and 0.9 term to the right side. We'll be having 0.1 minus 0.9 be equal to e power t into 0.03, and this will be 0.1. If we take ln on both sides, we'll be left with ln of 0.1 minus t into 0.03. Then solving this, we'll be having ln of minus 0.01 by 0.03 will be equal to t. If we solve this, this will be ln of 10 by 0.03 which is approximately equal to 76.7 minutes. It's- yeah, yeah, that's it. So we found all the answers for the questions they asked. So 90% of the fish shall be filled in 76.7 minutes, and the differential, like solution for the differential equation is this: